This course is to introduce you to a couple of the common industrial sensors. For example, proximity, temperature, pressure, and level sensors. No previous knowledge is required, as I will take you through an overview of each sensor covered. However, having some knowledge of electronics foundations, industrial systems, and basic PLC programming helps. To understand where sensors fall within the industrial systems, you can check out this course, Learn Industrial Automation. If you need a refresher on the basics of electronics foundations, I recommend that you check these two courses, Electronics Foundations, Basic Circuits, Electronics Foundations, Fundamentals. In industrial processes or manufacturing, controllers, the physical device, cannot hear, see, and monitor processes by themselves. Therefore, industrial control systems use industrial sensors to help controllers perform their tasks. Industrial sensors are within the field level of the automation system. They are used to check, for example, temperature, flow, speed, and pressure during any part of the process within industrial system. They can also be used to check whether parts are present or absent, size and color of the part, and whether or not the product is good or defect. Sensors can sense physical inputs like mechanical, thermal, optical, and chemical variations. They convert that into electrical signals like voltages or currents to send them to PLC for controlling and monitoring. Usually, sensors are categorized by what they measure, such as temperature, pressure, level, flow, etc. You can see here categories from Emerson Automation. Here are some examples of different industrial sensors: temperature, proximity, pressure, level measurement, and flow sensors. A common classification of sensors is contact and non-contact. If the sensor must touch an object to sense it, the sensor is classified as a contact sensor. Non-contact sensors can detect the object without touching it physically. Proximity sensors are devices that detect the presence of an object without physical contact and then convert the information into an electrical signal. In general, proximity sensor has a cylinder shape with a flat surface on one side, looking like this. Here are examples of different proximity sensors from different manufacturers. They are encapsulated to protect the device against excessive vibration, liquids, They are encapsulated to protect the device against excessive vibration, liquids, and corrosive chemicals that you might find in industrial environments. And here are examples of how proximity sensor shape with a flat surface on one side, looking like this. Here are examples of different proximity sensors from different manufacturers. They are encapsulated to protect the device against excessive vibration, liquids, and corrosive chemicals that you might find in industrial environments. And here are examples of how proximity sensors are mounted when used in industrial settings. There are different types of proximity sensors. Here are some of the common ones: inductive, capacitive, magnetic, ultrasonic, and photoelectric proximity sensors. Proximity sensors provide a high-speed response, so they are used when rapid response and high switching rates are required, such as in counting or ejecting control applications. They are also used when the object has to be sensed through non-metallic barriers, such as glass, plastic, and paper boxes, or when the object being detected is too small, lightweight, or soft. Proximity sensor is an example of non-contact sensor, making them a good choice when long lifespan and reliable services are required. Here are some demonstrations of different applications for proximity sensors. Examples: capacitive proximity sensor is used in wood industry, and inductive proximity sensor is used in metal part detection. There are different types of proximity sensors, so knowing the target object matters in selecting the type of proximity sensor used, like knowing its material, shape, dimension, color, speed, and the package, whether it's a glass or plastic. In general, the operation principle goes this way. The object serves as a reference for measuring. Then usually the sensor gets calibrated, knowing the distance between the sensing surface of the proximity sensor and the target. Each sensor has a sensing area, meaning a range that can operate within, so the sensor can detect the object anywhere within the sensing area. The sensor detects the changes as a transition. The output data of a proximity sensor can be either analog or digital. Digital output is 0 or 1, an on or off state, and transferred to a PLC digital input module. Analog output, either voltages, usually 0 to 10 volts, or current, 4 to 20 milliamps, and it's sent to a PLC analog input module. You see here an example of proximity sensor detecting objects from distance while they pass on a conveyor belt. Now, the different types of proximity sensors use different operation principles to detect the object. The idea is the same, but the operation principle is different. Therefore, they are classified according to their sensing operation principles and the target materials. I will cover the two common types of proximity sensors: inductive proximity sensors and capacitive proximity sensors. Inductive proximity sensors are used to detect the presence of metal objects. Metal objects, including both ferrous metals containing iron or non-ferrous metals such as copper, aluminum, and brass. These type of sensors operate under the electrical principle of inductance, and hence the name, inductive proximity sensors. The operation principle in general is based on detecting the presence of nearby metallic objects by measuring the changes in magnetic fields. Here are a couple of examples of using inductive proximity sensors. Applications like counting metals on a conveyor belt or gear tooth detection for motion monitoring. Other examples like in beverage processing applications. Inductive proximity sensors are used for counting metal cans or for position detection. Notice in the examples here that inductive proximity sensors are used whenever there is a metal target. Here are a couple of examples of inductive proximity sensors provided by Eaton Automation. You can see here that each design is used for a certain application. Other examples are from Rockwell Automation.